All right, so now we're on the level 4, which we're going to get into more complicated polynomials where we need to factor them completely. In number 1, I remember start off with GCF. It doesn't look like there's a GCF. So for this one, since there's 4 terms, we will need to start off with grouping right away. The greatest common factor out of my first 2 terms would be a 4n squared. When I factor that out, I'm left with an n plus a 3. I would need to factor out a minus 1 out of my next 2 terms to be left with an n plus a 3. So I have a 4n squared minus a 1 times an n plus a 3, which some of you guys are probably like, all right, that's your answer. That's good. We can move on to the next one. But in fact, we're not finished. Because if we look back at this polynomial right here, this binomial is actually a difference of 2 perfect squares, because 4n squared and 1 are both perfect squares. So we can factor this binomial further. I'm going to take the square root of my 4n squared and the square root of 1 and subtract those. The square root of 4n squared plus the square root of 1. And then I can put the n plus 3 on the end, and now this is fully factored. Looking at number 2, it looks like there is no GCF to start, so we can jump straight into the grouping method because there are 4 terms. So doing my GCF out of my first 2 terms, that's going to be a 4m squared, and then I will be left with a 2m plus a 3. I would need to factor out a minus 1 out of my next 2 terms to be left with a 2m plus a 3. So I have the following: 4m squared minus a 1 times a 2m plus a 3. We're not finished because this binomial is a difference of 2 perfect squares, so I can continue to factor that. The square root of 4m squared minus the square root of 1 times the square root of a 4m squared plus the square root of 1. That was a difference of 2 perfect squares. And then we add on the 2m plus 3 at the end, and this is your fully factored answer. All right, number 3. We do not have a GCF. And if we start off using the grouping method, we actually can't factor out anything out of these 2 terms. So for this one, we're actually going to need to rearrange the problem. I'm going to pair the 9mz with the plus 3mc, and we're just going to test to see if this works. And then I'm going to pair the minus 4nc minus the 12nz together. Now I'm going to jump straight into grouping from here because there's 4 terms. The greatest common factor out of the first 2 terms would be a 3m. And I'd be left with a 3z plus a c. My greatest common factor out of my next 2 terms would be a minus 4n. And I would be left with a c plus a 3z, which these 2 parentheses, even though they don't match exactly, technically they do, because addition is commutative. So you could rewrite this set of parentheses as a 3z plus a c, and it means the same exact thing. So the parentheses are actually identical. So one of your binomials would be a 3m minus a 4n, and your other binomial would be a 3z plus a c. And if you look back at these 2 binomials, they cannot be factored any more than they already are, so that is our answer. Looking at number 4, if I jump straight into the grouping method here, I can factor something out of my first 2. I'd be left with a v plus a 1. However, out of my next 2, I can't factor anything out. So right now, as the polynomial stands, we would not be able to use the grouping method. But if we rearrange our terms, we might be able to. Let's pair the 30uv with the 36u squared. So let me rewrite this problem. And then I'm going to pair the plus 30u with the 25v. All right, and let's get started. Grouping, using the grouping method between my first two terms here, both are divisible by 2. I apologize, both are divisible by 6. That's our greatest common factor here. A 6u would be what we're pulling out here. And I'd be left with a 5v plus a 6u. Out of my next two terms, I'm going to pull out a plus 5, and I will be left with a 6u plus a 5v, which again, these two that are in parentheses, since addition is commutative, these technically are the same exact set of parentheses. So one of your binomials would be a 6u plus a 5. And your other binomial, I don't care how you write it. You can write it as a 6u plus a 5v, or you can write it as a 5v plus a 6u. It's up to you, but that's your answer. And if we look at both of these binomials, they cannot be factored further like we did up here in numbers 1 and 2. The level 4 doesn't have to be a polynomial with 4 terms. Remember, if you have 3 terms, we could still that could still be a level 4. 3 terms would be box method or X method. So make sure that you understand that. And I want to stress over and over and over that we should always start off with taking out the greatest common factor, which we didn't have a greatest common factor in any of these, but you might in the future. So make sure to take out a greatest common factor first if there is one. And that brings us to the end of level 4.